Hi guys, welcome to Learning Electronics Repair, and I have Detlef with me today. Yeah, we have quite an interesting thing to talk about.
I hope so, yeah.
So this is something that Detlef found at the car boot sale.
Yeah.
For not much.
I think €5 or something.
Yeah.
Yeah, for a roll-on drum machine from the 80s, yeah.
Yeah, and there's a problem.
Yeah, and a weird one, yeah.
Okay, Det, so what's the problem? What's this?
So if anybody recognized this little jack there, he's really good, because I only knew of this drum machine and the sister one that uses this weird connection over here. So you see, you got plus and minus 10 volt, so 20 volt in all with a ground connector.
Yeah.
And actually, this connector was never used again, and I have no idea why they used it there. And you see my problem there, because we got this drum machine without the power supply. This is why it was cheap.
This is a real pain in the neck. Why they did this? Because, I mean, if the power supply picks up, oh, you've got to go back to Roland and buy another one. That's why.
Don't know. If you can get it's probably 70,
yeah,
horrible amount of money.
Horrible amount of money. Okay, so that's the problem. But this problem applies to lots of things. So we're going to talk today about how we can actually run something like this, which needs a plus and minus volt supply from just a single supply rail.
Yeah, because
well,
you can't get these power supply, and even if you can get one, these may fail, or the cable breaks, and if the cable breaks, you can't fix it because.
Yeah,
horrible idea. Yeah,
it was. So we actually have a schematic of the power supply to this. And I'm just going to, we're going to show you the schematic now, and then explain why maybe what would appear to be the easy solution is not really possible. Okay, guys. So this is actually the schematic, at least of the power supply section. You can see we have the power comes in here, plus and minus 10 and ground. Now, I'm just going to go over this a little bit because Detlef and myself were discussing how we think this works. You'll notice that we actually have here from the plus 10, so this is your plus 10 coming in to a diode to a voltage regulator, 7805. So this is a 5 volt regulator, and coming out of here is 5 volts. You can see there, plus 5, to a filter, some capacitors.
Yeah. So this is a good information, because we know that the plus 10 gets converted to plus 5.
Yeah. And this diode, by the way, is for protection. So if you reverse that polarity somehow, then it wouldn't conduct. So that's what that's doing. We'll come to this bit in a minute. Yeah. So that's your plus 5. We can see plus 5 volts, yeah? Now, you would think, or I would have thought, that you would have put here a 7905. Well,
that's my first thought, yeah.
That was my first thought. Yeah. But what they've done, if you look at this, is they have a resistor potential divider here from the plus 5, which is putting the voltage on the base of this transistor, and this is a PNP transistor, so that effectively puts a voltage on here, and the voltage on the base here will be basically dependent on these two resistors. So this basically forms your negative supply there, yeah, your minus 5. But this isn't regulated, so look, there's no voltage reference in here, there's no Zenith diode.
Well, it depends on the 5 volts, right?
Because, it depends on the 5 volts.
The resistive divider would be something, you get a voltage on there, and somehow my analog flow isn't strong enough. I would use a 7905.
Personally, I would. And also, actually, you notice this voltage divider, one end of it actually goes to the output, which is the output from this transistor.
Yeah, I know.
So, interesting. So, what you can see, guys, is the negative supply comes in this way, through the diode, to here. And we have plus and minus 5. Now, you might think, and we thought, well, let's just stick plus and minus 5 in here and problem solved.
Bob's your uncle, right?
Yeah, Bob is your uncle. However, we have this thing. So, yep. This is going into the circuitry somewhere. I don't exactly know where, but what we have here, Luke, from the plus 10 to ground, a Zenith diode, 5.6. Yeah, puts the voltage onto here. Another Zenith diode, which looks like an 11 volt, just guessing that one. And the way I see this personally is that if this Zenith is conducting, so there's enough voltage here, it'll turn this transistor on, collector will come down, turn this one off, so the collector goes up, and this one will turn. Oh, this is PNP. So actually that goes up, this will turn off. Yeah? And the voltage here.
And this thing is connected to
minus 5. Yeah. So to switch this, the voltage here has to be less than 11. That's what I can see of it.
Something like a power good circuit for the negative voltage or something.
Well, you notice we have 5.6 here.
Yeah.
So that should be fixed. 5.6 as long as the supply's here. And the other end of this Z, it goes to the -5. So that actually gives us about 10.6. So it's either going to be something like an under voltage detection.
Oh yeah, that could be.
Or something that says that if the -5 is absent, then this will switch and send a signal.
Yep.
So it's either a protection or something. But because of what this is doing, we decided we couldn't just put voltage in here and just leave this off.
Yeah, that was the whole reason to think this further. Yeah.
Yeah. So you guys, what do you think? If you got a bit more clarity, I think I've got some good idea that what this actually is doing. But maybe some of you guys, talk about that one yet.
Yeah.
Down there. Okay, so you can see we need to solve this problem. We need to somehow get a plus and minus 10 volt supply DC into here. And we actually came up with 2 completely different solutions.
Well, 3, because the cheapest one I just thought about, you could use 2 9-volt cells.
Oh, well, 3. So we could use 2 9-volt batteries. That would probably work. Yeah, I'll go with that.
Yeah.
But other than that, I have one solution and Det has another. So not only do we have 2 solutions, but we have a conflict of
Yep.
which is the better. So we're going to show you the 2 different ways each of us would do this in a different way. And then again, you, and probably you and him over there, can...
Yeah, back there.
Oh, and you in the back, yeah. You can tell us who you think came up with the best answer. So to do this, of course, we need a piece of paper. The ubiquitous piece of paper.
Dicky cat, they call this.
Oh, Dicky cat, that's the one. Yeah. Not anything to do with the earplug there. And our paper needs to be drawn on. So this is my idea. We take a laptop power supply. We know these are 19 to 20 volts. So we'll take our 20 volt positive laptop connector. The other end we know is 0 volts or ground. So we have a positive 20 volt supply. How do we get a plus and minus 10 out of that? Well, it's actually quite simple. So if we take the plus 20 and we take this into our Roland, so this is the plus 10 volts connector.
Yep, plus 10. Yeah,
plus 10.
Just set to plus 20.
Exactly. And then we take, it's on the plus 20, but this is the clever bit. So what we now do is we take a voltage regulator 7809. That's a 9 volt positive regulator. Okay. And your voltage regulator, as you will know, if you do know these little 3-pin regulators, you have a ground pin, which goes to ground.
You need the caps.
Oh, we need the caps. So yes, I actually put the caps on. So we need 2 fairly small, not that critical electrolytic capacitors. One here and one here. And we connect it like so. We've now got here plus 9 volts. But yes, I wanted 10 volts. So what you can do with these regulators, you could put a Zener diode in here and a resistor, but if you just want to make a small difference to the voltage, make it a little bit higher, you can do this. You can take 2 normal diodes. I used one M407, and each diode will add about 0.5 of a volt. So 7809 plus a half is 10 volts. So what we've now got here is plus 10 volts. No, we have. I've drawn this wrong. This is the plus 20 volts. Okay, this will make sense, guys. Yeah, and we've got 0 volts. So what we've got now is we've got a ground. Yeah, we've got a plus 10 and a plus 20. Now you might think that doesn't help, but it does, because voltages are all relative to each other. So if we connect this is the Roland, and we connect this to the ground on here, and we connect the 0 volts to the minus 10, and we connect the plus 20 to the plus 10, we've actually got what we have and what we need.
Yeah.
Now, you guys might say, yeah, but Rich. So I'm just going to prove to you this is actually the case, because I've built one of these. So let me actually show you the thing. Okay, so here's the barrel jack. I've wired this up so the blue one is ground negative and the white and blue is positive. And if we measure across here, which we'll do now, ground to the positive, we have 19.9 volts. Okay? if I go on here, this yellow wire, you can see this is connected to the ground, yeah? So if I connect my meter ground to here onto the yellow, we will in fact have, and we'll see.
Should I hold anything?
Yes, can you hold that one in there, Detlef? Oh, I've got it.
Oh, clever.
Clever. Okay, so if we now go to the red, we have 19.9 volts.
If you're wondering what these connectors are, Rich sacrificed a Molex.
A Molex connector, yeah. And if we go to the black one, I'll show you what we're doing. If we go to the black one, we have plus 10 volts. And this is the clever bit, as I say, if I connect
the ground to
the black one
to the black one.
Yeah, the black one to the black one. So that's the output from my 7809. If I connect to there, I now have plus 9.66.
Good enough.
Good enough. And I have minus 10.3.
Ta-da!
So guys, you can very easily make a plus and minus supply out of just a positive supply.
And probably from components you have laying around.
Yeah. The advantage of this is, this is fairly scrap components. It's just a voltage regulator.
20 PCB around so people can see what's on there.
Yeah, I'll show you.
Yeah.
So we literally have the two capacitors, one from the input of the regulator to ground, one from the output to ground. These two tracks absolutely bridge together. This is all just ground, okay? We have the two 1M4007s in series from the ground pin on the regulator to the real ground. That adds the 1.2 volts roughly. And this is the input, so that's all we have. Yeah. If you didn't have a 7809, but you had something like a 7805, you could either use more diodes in series, or you could use a 4-volt Zener. Yeah, so if you only have the 7805, I'll just show you. We put here a 7805. We don't have these diodes, we now have a Zener diode, 4 volts, and we connect a resistor to here. So you can put this together pretty much out of scrap. I just use a bit of variboard. You could put this into a little enclosure if you want, put the barrel jack so it was actually in there. So guys, you can see my solution to this problem. But Detlef wants to do this a different way. So Det, come on, tell us how you'd like to do this and why it's different.
For once, I have a few caveats with that. For once, the barrel jack of the notebook power supply. I have a notebook power supply somewhere, probably. But you know me, if I have a power supply somewhere, I'll probably get it. And when I have it, this barrel jacks, there are about 1,000 versions of these. And when I get a power supply, I probably have the wrong one. So I will be running around for 10 minutes looking for the right power supply until I find one, and then I probably have forgotten what I want to do on the drum machine. So this is not ideal for me. So what is the connector that is everywhere around?
USB-C?
Yes, USB-C. Everything is run by USB-C these days. So my decision would be use USB-C for that.
What, use a 20-volt USB-C like I was using a 20-volt laptop?
You could do that. You know this little cable one that's just lying over there? You might maybe want to show the people. This one. Yeah.
These ones?
Yeah, these are clever things. Because, there's a barrel jack, I know. But you put this into a USB-C power delivery power supply, PD.
PD, yeah.
Then this talks to the power supply and tells the power supply, hey, I need 12 volt, give me 12 volt. And it does. And
I assume you can get these to give you other voltages like 9 or 20.
Yeah, I had this one with me for, because 12 volt is the obvious one, but you could get these for 20 volts. So it was very close to your circuit there.
Okay, so I've connected this cable to a USB-C PD power supply. Let's see what we actually have coming out of this then. Yeah, we have 12 volts.
12 volt, there it is. Yeah,
yep, there it is.
Yeah. So if you got old equipment that needs somehow 12 volt or 15 volts or 20 volts, this is the cheapest way to get this running with a barrel jack. Sadly, we don't have a barrel jack. Damn it. Yeah.
Damn it.
Damn you, Roland. So we want to have a USB-C connector in there.
Oh, a big round USB-C connector enclosure thing.
Look at this. There's a big round USB-C connector with a little connector. So this goes USB-C to USB-C. And the little thing you see down here is a decoy, they call it this way.
Okay.
Yeah. So this talks to the power supply and tells the power supply, I want to have something volts. And this is set to, okay, look, there's
9, 12, 15 or 20.
Yeah, there's no marking on there. So this is set to something on there.
Okay.
Yeah, this would be my solution here, because now I have USB-C. And I have something like 20 volts.
Okay, and that then would go into something like my little adapter.
Could do that.
Okay.
But I kept thinking there, and I thought, okay, now I need, if I want to power this won't draw a lot of current. If I want to power this, I always need a PD capable power supply.
Yeah.
I can't run this on, say, something like this cheapo power bank here. So this cheapo power bank here.
This thing. Okay.
This is just a 5 volt USB, a very dumb one.
Okay.
And yeah, it's 2025, I know, but right now I don't have PD everywhere. And I like my old USB power supplies, so I like this one.
Yeah, I see.
So I thought, okay, can I get a solution here that only runs on 5 volts? So make the Roland run on 5 volt.
And I take it you're going to generate the plus and minus 10 from a 5 volt supply.
Indeed. And for this, we can switch the connectors. So I got this little USB-C connector here, and you see the little resistors down there, the R1 and R2. These are there to tell the power supply, if it's an intelligent one, please give him 5 volt with something 1 amp or something.
Yeah.
Yeah. So this would be my choice we can set this somewhere in the housing. So I only have a USB cable going into the Roland.
Okay.
For power, which I think is pretty elegant.
Yeah.
Because I don't have to look around for a barrel jack somewhere and don't find the right one.
That's okay, Deb, but we still need to get the plus and minus 10. So how are you going to... You're going to tell us now you're going to get plus and minus 10 out of a 5 volt supply.
You know what? AliExpress is your friend.
Module.
Ta-da! Yeah, I know I probably could design this myself. But when it comes to these things, I'm pretty happy with using tested designs. Because if I would design this, I probably need at least 1 or 2 iterations there until I have it working. And I pretty much want to get the Roland running and don't want to design a power supply. So this is me being lazy, and you already can tell with an electronic pointing device. V in, so we got a voltage in over here, which is 5 volt in our case, and we got a plus, ground, and minus volt output.
Okay.
Let me show you the AliExpress thing for that. So this is a DD1912PA 2-in-1 8 watt, blah, blah, blah. Pause the video. If you want to get one of these, pause the video and get this description. It doesn't make sense to get you any links, and in 3 months the links will be gone. Yeah. So look for this description. The DD1912PA will probably be the thing you want to look at. So this inputs something volts, 3 to 20 volt, and gives you 5, 6, 9, 10, 12, 15, blah, blah, blah volts at an output.
So you're using the version plus and minus 9, or plus and minus 10 for that matter.
The one selected down there, yeah. Because we'll get away with 9 volts, and this is a module in real life then.
Okay, so literally we just connect the USB C connected to the input.
We get this USB-C connector.
We connect this to the PCB. Are we gonna solder this onto the PCB?
So this is actually the PCB of the drum machine. We just removed the back cover, so we don't need to remove anything else because it's already here, and you can already tell minus 10, and there's a plus 10, and there's a ground tab. So this is the backside of the little weird connector, and we simply slap on the 3 wires on here.
Okay, and
we should be running.
Shall we try that?
Let's go. So we got the little USB-C connector here, and we got the power converter module there, and we have a cheaper power bank. Okay. So we can test how much current goes in there.
Interesting. Let's turn this over then so we can see whether it's working. And there you go, guys. So song 0, maze and pin.
How much current is going in there?
Let's have a look what this is drawing. So sorry about the focus, a little bit awkward when we're doing this.
It's about 1 amp.
Okay, so 1.09 amps, 4.93 volts. And the thing is working. You can see it on the display there.
And the bloody thing is working,
Okay, guys, so that is basically how you do this. You'll see there's 2 different solutions there. I'd be very interested to hear from you guys which one of those you think would be the best way and why?
Yeah, and you followed this train of thought. So there are multiple solutions. This is just where you go for, okay, what do you want? For me, this was important to get USB-C in there to have a ubiquitous connector there.
Yeah.
Don't have a barrel jack. This was my whole thinking there. And now I can power this thing from this cheapo, we got this on a for €3 on a flea market power bank. I'm with you. This won't run long with 1 amp output.
Yeah.
But you know what? If I want to power this with something, I can use the cheap wall wart.
Yep. Nice one.
Yeah. And since this is now USB-C, you can connect to USB-C. Yep.
Yep. You know what? You're quite convincing, Detlef. That's quite difficult to argue with.
Sorry.
No, seriously.
Yeah. So if you want to have these little USB-C connectors with the resistors on there, there you go, €2 for 10 pieces.
Oh, yeah. For 10?
For 10,
yeah.
There's no reason to build this any.
These are cheap as chips.
Yeah, they are.
Absolutely.
Yeah, they are. 20 cents per connector, so you can't go wrong there. And if you want to have something that only inverts voltage, so say you have 10 volt in and you want to have minus 10 volt out, that would be the solution for this one. This was a step in between. I actually have them on the desk over here. But we never use these. So this inverts voltages.
So you can, is there a maximum, what's the, up to 15?
Yeah, to 15, yeah.
Yeah, nice. So there's lots and lots of these things available, guys.
Yeah. And they pre-made modules. You don't have to design this yourself. Go for the pre-made modules. You probably can't do this as cheap as they are. For $2, I can't design this.
Yeah.
Even with PCBWay in the back, I can't design this. Yeah. And I have to try this before I can be sure, okay, this will work.
Okay.
Yeah, this would be my solution, yeah.
Okay, nice. So, some interesting things to discuss, guys, then. Which you think was the best solution? Would you have had a different solution? Does anyone you want to elaborate on this circuit?
Yeah, true.
Yeah.
I'm off with the analog stuff here.
Yeah,
so,
and I'm kind of got an idea. Okay, guys.
Yeah.
Over to you. Well, guys, we have an epilogue on this video. We were on a little bit of a tight schedule with Det and myself. So, you probably wondered why we didn't demonstrate this working on the drum machine. And the reason is that we tried it and it didn't work as we expected it to. What happened is that the positive supply went up to about 14.5 volts or roughly. And the negative supply went down to about -5. So effectively, the ground was shifted. The total voltage was still correct, 20 or thereabouts, but the actual position of the ground changed. Yeah. So we disconnected and we didn't want to connect it on again. It didn't damage the drum machine because you saw after that we did Det's method and that worked fine. At the time I said to Det, I'll have a look at that and then if I can figure out what's going on, I'll record that bit and insert it. The magic of editing, yeah. So I had a look at this. Now I'm going to show you what's going on with it because it's quite interesting. Now in the video with Det's converter, we could see from the USB-C it was drawing about 1 amp. So that was the actual load that was present. So I decided to emulate that with some power resistors. These are 20 ohms each, so 10 volts, give or take. 20 ohms is about 0.5 of an amp, and 0.5 of an amp off the negative 10. So this will give about 1 amp of load, the same. We'll connect this to my little converter, so the junction of the 2 resistors to the ground. 1 resistor goes to the negative and the other one to the positive. And there we have our load attached. Now let's try it and see what we get. So from ground to the positive, 9.4, just dropped slightly, to the negative, 10.24. So with the load attached, we still have effectively plus or minus 10, give or take. So that isn't what caused the issue. Let's have a look at the schematic again. Sorry about a bit of mess on this printout. This is your +5 and this is your -5. Okay, and you can see the +5 comes from the voltage regulator, The -5 is generated by this little circuit we were talking about. This then has the inductor coil filters on and extra capacitors. This doesn't. And that's because the +5 on the drum machine powers the little microcontroller, the logic circuitry, and will be the positive supply to the op amps which are feeding the audio. Yeah? And the negative only supplies the op amps, negative rail. So that means, and that's why there's the inductor on here as well, by the way, that means that there's more current going this way than there is, well, I suppose I'll draw it the opposite way around because it's flowing the opposite way, that way. And that, I think, is what upset my circuit for some reason. So let's prove this and see if that is the case. Well, you can see I've increased my tangle of wires. So now I have the common coming onto the junction of the 220 ohm resistors. The orange one actually goes to a white lead here, which goes to the red. So that's the positive through 20 ohms. And then the negative comes through the 20 ohms down this wire to here. So this is another 200 ohms. And out of the 200 ohms then goes to the negative. So we now have, roughly speaking, about half an amp on the positive rail and about 50 or a bit less milliohms on the negative. Let's see what that actually does to the circuit. Put the power on. We'll just check the voltage coming in again. 19.87. Okay. This is our ground point here. What's on the positive rail? 2.4. The negative? -17.45. So you can see that the ground point is actually moved upwards. This will probably make more sense if I measure from here. So we'll just show you. So this is the ground from the laptop power supply here. Okay. The black lead now has 17 volts on it. Okay. And then the red lead will have the 20. So it appears that if I load this like this, it works. And if I load it like that, it doesn't. We'll also see this just as clearly if we measure the input and output of the 9-volt regulator with reference to ground. Okay, so I put my black meter lead on that yellow one. That connects directly to the ground coming in. It's across this part of the Vero board. Okay, let's do this and let's have a look at the voltages on the regulator itself. So in 19.8, out 17.46, and 1.4 on there, which is the two diodes in series. So guys, when you load it like that, the regulator doesn't regulate. And I'm pretty sure I can see why that is. So if you look at the circuit, we have 20 volts here, we have 0 volts here, and we have effectively the load is forming a voltage divider. So when they're both the same values, the two resistors, the voltage here would basically be half of that. And that's what happened. When this is 20 ohms and this is 220 ohms, this is 10 times less than that, a bit more. So that means that most of the voltage, 10 times whatever that would appear here, or in other words, if you like, this 20 ohm resistor is also forming a current path to here, the same as that is forming a current path to here. So the regulator can't regulate. I probably should have seen that coming. Yeah. So this circuit doesn't work in the way that I originally expected. Maybe some of you would notice that. I do know somebody on the live stream had also suggested this, so there you go, it doesn't work, and that is why, or rather, it doesn't work if the current that's being drawn between the two loads on the voltage rails are different. Okay? So I think we all learned something there today. Hope you enjoyed that, and I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now, guys.